Hey, my name's Aryan and this is the 2013 Long Free Response Question 5. A sample of C2H4 gas is placed in a previously evacuated 2-liter container and heated from 300 to 450 Kelvin. The pressure of the sample is measured and plotted in the graph below. And in the graph you can see as time goes on, the pressure of the gas linearly increases. Part A. Describe 2 reasons why the pressure changes as the temperature of C2H4 increases. So if you look at Pivnert, you know that increasing the pressure increases the temperature and decreasing the pressure decreases the temperature because both those variables are directly related to one another. And the definition of, before we look at this, we know that the definition of pressure is the number of collisions that are exerted on the walls of the container. So as the temperature increases, there's an increase in the average kinetic energy within the molecules themselves, therefore increasing the number of collisions with the container. Which is obviously means that the pressure increases. The second reason is that the increased temperature actually increases the speed of the molecules, therefore increasing the forces exerted on the container, which thus increases the pressure. Part B. When HCl is injected into a container of C2H4 at 450 Kelvin, the total pressure increases. Then, as the reaction proceeds at 450 Kelvin, the total pressure decreases. Explain the decrease in total pressure in terms of what occurs at the molecular level. So if you increase the amount of HCl at 450 Kelvin, the reaction shifts to the right, which creates a total of fewer moles in the system because there's only one product when there's only while there's 2 reactants. Therefore, the decreased amount of moles means decrease in collisions, which decreases the pressure of the reaction. The next part has two steps of a mechanism, and part C asks, write a rate law for the reaction that consists with the reaction mechanism above. So in order to find the rate law, you have to look at the rate determining step, or the step that's slower and takes the most amount of time. So for us, it's just step 1, so our answer would just be rate equals K, which is the rate constant, times C2H4 to the first power, which is first order, and HCl to the first order or first power. Part D. Identify the intermediate of the reaction in the mechanisms above. C2H5 plus gas and HCl are both intermediates of the reaction, and the easiest way to remember this is catalysts are things that make a reaction faster, and you add them to the beginning of a reaction. So you know that a catalyst would be in the first part of step 1 and reappear at the end of step 2. Therefore, a intermediate would appear at the end of step 1 at the beginning of step 2. Okay, and the last part, E and F, basically both ask to show an energy change and make a graph that shows the energy change in the second step mechanism. So identify delta H and label the activation energy for the rate determining step. Because there are 2 steps, there are 2 bumps, and the first step has to be higher or greater in potential energy than the second step because it's slower, which means that it requires more energy to overcome that step. Therefore, and then you can also see the activation energy labeled in my graph. Thank you.